We've had some functions on pretty much every data type we've brought in. So let's quickly just run through a few functions that are available for strings. I'm going to go back to my handy dandy notebook. We'll come into here. Let me grab scores and Pluto or planets. Okay, and we can look at, now we can just type scores. I'm going to throw this over there for now so we have a nice, and we can look at planets. Okay, so now let's start looking at some functions. You know that if we do an import math, we can then do a help math. And we can always do a help string. And we looked at a couple other ways that we could get help on different data or different types. Right? Well, turns out that if we want, we can also get help on lists. And if we do help on list, what we find out is that there are a lot of functions: index, extend, count, copy, add, contains. There are a lot of functions that are defined on lists. We can do so there are, so we can get a lot of help on lists. Lists is an object. It has a help function. We're not going to do all of those, but we will do some of those. The other interesting thing is if we want to do something like, right, I just did a help lists. If instead of asking for help lists, planet is of type lists or planets, so I can actually ask for help on planets. And I get exactly the same help function, right? So you can always ask on either variable of a type or the type itself. When you ask for the variable of the type, it will tell you that it's giving you help on the list object because, in fact, the type of planets is a list. Okay, type of planets is actually a list. Let's look at some basic functions. Let's do help sum. Right, sum is a built-in function. It's not a member function of the list. We'll show you some of those in just a minute. But sum goes through and it adds up everything in a list. So if we want to do sum of scores, right? We want to find out our scores. Well, the sum of our scores is 436. And you guys can check that if you want. It seems reasonable, right? We're right around 60 for most of those. 7 times 60 would be about 420. So I'm willing to believe that. So that works. And we can even put this into and we can do max scores. That'll pull out the maximum. Right? Remember before we did max, something like 34 minus 17, 12. So we gave it a list of values. Well, we can also just give it a list, or we gave it a sequence of values. We can also just give it a list. And if we give it a list, it'll pick out the 68, which is the highest one, or it'll pick out, if we ask for the min, it'll pick out the smallest one. Right? And in the notes, let's go down to the notes. Oh, I was supposed to at some point get rid of mraz. Okay. And if we want, we can even do something like this. We can embed that in a print statement, right? So let's look at what this one does. Well, we know that the sum gives us, well, the sum adds up all the elements in the list and gives us the sum. So if we take the sum of a list and divide by the length of the list, what are we actually calculating? This is often on an exam. What we're actually calculating is the average, right? The sum divided by the number of elements is the average. So make sure you know how to do that. It's a simple one-line calculation to get all of the values. Let's look at planets again. Mraz is bothering me, maybe. Mraz is at 3. So we can actually go in and say planet sub 3 equals Mars in case we made a mistake. If I can type. There we go. And now we can look at planets again, and we should have our Mars instead of Mraz. So those are 3 functions that go through. You'll notice that sum, min, and max returned a value, but they didn't actually change the values, right? Scores is still the good old list that we knew and loved. Well, when we assigned Mars to Mraz, that changed the list. And there are other functions that change the list as well. This next part is a really confusing part. So I want you to pay attention. One of the things that you can use to change the list is you can sort it. So we have our Mraz, our planets. You know what? Before we do that, let's try one more thing. We did the sum of scores. We didn't do sum of planets. Any idea? What's going to happen when I enter that?
Professor Turner, I think I have a guess.
Go ahead. Shoot.
I think it's just going to concatenate everything.
That's what I would have done. Unfortunately, it doesn't, which is annoying as heck. I have tried before. Every time I teach this class, I try to make it concat because I can't believe that that's not what it does. It won't calculate anything. It just blows up, and there's no reason. Well, you know, from a semantic reason, from a abstraction reason, there's no reason for that not to work. So I've got to figure out what they're doing in there that makes this not work. It is allowed to work. Let me rephrase this. On our particular Python, it doesn't work. It's not required to work on any Python, but it's allowed to work, which is kind of a dangerous middle ground. It should just concatenate. That would be the right thing to do, but it doesn't, which sucks. Anyway, that was an excellent guess. That was what I would have done as well. Anyway, so now we're going to get into sorting, right? And so we have our scores, and our scores are not in sorted order. Our scrows are not in sorted order. Our crows, whatever we want to say, they're not in sorted order. But if we do scores.sort, right now we're taking the list scores. We're using our dot notation to call a method that's defined on a list, right? Sort is right. Sort is one of those functions that's defined on the list. If we do scores.sort, what we're going to find out is that scores doesn't return anything, right? It returns a none. In fact, let me do this. Right? It returns a none type. But what it's done is it's now modified scores. Right? That was an excellent guess, by the way. That sum should work. That's my biggest peeve with Python, and that's pretty big. Anyway, this now gives us a sorted list. So this is not the same as scores was just a few short lines ago, right? It used to be this. We did the sort, and now it's this. So sort actually changes the scores function, the scores list. Let's look at planets. Now the sum didn't work, but it turns out, this is why I'm so irritated with the sum not working. It turns out that planets.sort does work. Right? Earth, Jupiter, Mars. So that works as well. By the way, as does max planets. It gives you the last one in lexicographical order. And min planets, which should give you the Earth, I think. First one in lexicographical order. Okay?
Oh, wait, it doesn't give you it in alphabetical order?
Remember what the difference between lexicographical and alphabetical? Alphabetical, it doesn't matter whether it's capital A or lowercase a. In lexicographical,
It
all the
doesn't.
capitals come first. It matters, right? So if we do min earth earth, it's always going to return the one with the capital
Wait,
first.
what if it's like Venus with a lowercase and Earth with a lowercase? Or sorry. If it's Venus with a capital and Earth with a lowercase.
Capitals always precede lowercase. Okay, so
Okay.
Venus with a capital comes before Earth with a lowercase. That's one of my other pet peeves. Is that's very difficult to grok to understand. Okay, all right. So we can sort planets. We can take min and max. Blah blah blah. We change the values. Lists are considered container classes. They hold things. So the order in which they hold things for lists is deterministic. You always get them in the order you put them. You always get them out in the order you put them in. If you put something in slot 0, it stays in slot 0. There are container classes like sets that we'll get to a little bit later that doesn't hold. But for lists, where you put it is where it stays. And it is a container class. And because it's a container class, we can kind of move it around. Okay, now here's the confusing part. And we are just coming up to the end of class, which is a good time for the confusing part. I get to duck out before you guys can ask me too many questions. Let's start out with our scores array again. This is in non-sorted order. Okay. We know that if we do scores.sort, we're going to reorder that list so it's in sorted order. But what if we want to maintain this list and what we want is another list in sorted order? So the sort method is a function, is a method of the list class. There's also a function sorted. And sorted returns a new list in sorted order and does not modify the original list. Okay, so you need to keep that. There's two ways to sort a list, and by the way, that works on planets too. Although I don't have the planets in non-sorted order anymore, so that works on planets too. But you need to know both of these. Scores.sort returns nothing, returns the none, sorts the list in place. Your list will be different when you get back from the sort call. Sorted of scores doesn't touch the list, but it returns a new list in sorted order. Okay, let's kind of run through quickly a few more things. I got 3 minutes. We are catching up. We are not exactly caught up, but that's okay because this will be on the next test, not this test, so we have a little bit of time. There are other things that change the values in lists. So we can do something like scores.append 75. And what that will do is it will add the value 75 onto the end of list, right? So we can do that. If we don't want to add it to the end, we can do an insert. Insert takes two arguments. The first is where you want to insert it. I'll insert it in the 0th place. And the second is the value you want to insert. And I'm just going to insert a string here just to demonstrate that you can have mixed lists of mixed types. And now if we look at scores, the 0th element is now here. The last element is now 75. If we want to do it in the middle, we can do scores 3, and we will put in the value 33333 because like lots of 3s. Okay. So we can insert there. Everything beyond the index where you insert at gets moved down one. The stuff in front of the index you insert at stays the same. Pop, scores.pop is a function. Scores.pop pops off the last value of the list. It modifies the list. Scores.pop with an index like 0 pops off the 0th element of the list, or the second element of the list, for example, if we look at scores again. Right? So it removes it from the list and returns the value that it popped. We can also do a scores.remove. And remove looks for a value in the list and removes it. And if it's not there, it removes an error. Okay? And if we have an empty list and we do a pop, that also returns an error, right? This is an empty list. Empty lists do exist. They're perfectly valid. Length of an empty list should be 0. Okay? These are flexible operations. They work on any of the container classes. Lists are our first container class. We'll look at other ones going forward. They're pretty fundamental. I'm going to hit one last thing in the last 30 seconds of class, just so we're kind of caught up, and that is lists of lists. I did this a little bit earlier in Python Tutor, but you can come in. Lists can hold lists as well as any other class. This list, L0, is a string. L1 is a GPA. L2 is a list. L3 is where they live. If we want to append onto L, right, let's say we want to append a zip code, we can either do it as a string or as a number. I'm going to do it as a number, 12180, right? We saw that we can access the courses the person's taken using 0, 1, 2. L sub 2 is a list. If we want to access a specific value, we tuck that specific value here. So L2 sub 0 should be math. L2 sub 1 should be computer science if I spelled this correctly as opposed to making a typo. Come on. There we go. Right? L2 sub 2 should be psych. And if we want to change psych to stats, we can say L2 sub 2 equals stats. And that'll change L as well. All right, so that's pretty much where we want to be at this point. We'll get more into these things as we go along, particularly lists of lists. This particular one is kind of like a record. It's, you can consider this student information, so it's we'll probably do either a lab or a homework using these pretty heavily. I'm done. You guys can go. Sorry for keeping you 2 minutes over, but I will hang out and answer questions on, for the next half hour, give or take, until you guys either leave or I get exhausted.